right, so we're on the last page, finally. All right, so given the sitting heights of adult males that have a mean of 914 millimeters and a standard deviation of 36 millimeters, use either the empirical rule or Chebyshev's theorem to answer the following as appropriate. So if the data formed a bell-shaped curve, what percentage of the data should fall within 2 standard deviations of the mean? So the first thing we got to do is just make sure we pick the right process or the right set of rules. So we either have the empirical rule or we got Chebyshev's. When it's bell-shaped, remember, that means it's the empirical rule. All right. So looking at the empirical rule, there was 3 possibilities. You either were looking at 1 standard deviation away from the mean, 2 standard deviations away from the mean, or 3 standard deviations away from the mean. And each one of those had a specific percentage associated with it. So you've got to know what those percentages are. Now for this one, they want to look at 2 standard deviations away, and that's just a fixed 95%. So that's it. But now they're looking at, for part B, what are the cutoff heights that encompass 68% of the data? All right, so that is going to have to be one of those 3 cases. So 68% turns out it's going to be pointing to 1 standard deviation away. So if you're 1 standard deviation away, all they want you to do is just look at these values to create those cutoffs. So again, that's 1 standard deviation away on the left side and 1 standard deviation away on the right side. So the middle, though, obviously is your mean. So the min cutoff would have to be the 914 minus the 36, which looks like 878 centimeters. And then the max, if we add the 36, looks like 950 centimeters. So again, you're always going to have 1 cutoff that's above and 1 that's below. So those should be our answers for that one. Now, for the next one, if the data did not form a bell-shaped curve, what percentage of the data should fall between those 2 cutoffs? Now, you can tackle this a couple of different ways. You could use the process we did back in 3.2, which was kind of a more of an informal process. And we kind of said, okay, well, we hopefully know that 914 is in the middle here. And we can kind of verify that by doing a little bit of subtraction. So if we subtract on this side and just subtracted those 2 numbers, we're going to get 108. And if we did the same thing on this side, you can see that we're also going to get 108. So that is good. We have the same amount on both sides, but now the question is how does this 108 relate back to the standard deviation? So up above, it shows you that 1 standard deviation is equal to 36 centimeters. So how many standard deviations should 108 be? Well, we can find that out quickly by dividing it. So if we take 108 and divide it by 36, that gives you 3. So now we know that we're 3 standard deviations away. But because this does not form a bell-shaped curve, that means we have to use the other rule that we have to use is Chebyshev's. Oops, forgot the Y. So Chebyshev's rule, Chebyshev's theorem, excuse me. So what does Chebyshev's theorem say about 3 standard deviations away? And so that is pretty specific. And that says at least 89% of the data should lie within 3 standard deviations of the mean. So again, if you memorize those, great, but if not, make sure you have that reference right there so that way you're not hunting around for it. All right, so now the last one wants cutoffs for at least 75% of the data. All right, so now at least 75, based on Chebyshev's, is 2 standard deviations away. So if we want to be 2 standard deviations away, it's going to be very similar to what we did up here, but now we're just going to subtract twice the standard deviation. So we got 914 minus 2 times 36, and just so we get it right, 2 times 36 is 72, so we're just going to add and subtract 72. So let's just do that real quick. Minus 72 equals 842. And then our maximum is going to be just the opposite, and we're going to add that 2 times 36. So 914 plus 72 is 986. And again, don't forget your units on these. So this one is talking about centimeters, so we want to make sure we include those units. So that would be our answer for part B. All right. Now for 15, find the z-score for the following height. Z-score is a concrete formula. X minus x bar all over s. So remember, the value always comes first. So 888 minus 914 all over 36. Now remember, do it deliberately in your calculator. So 888 minus 914 equals a negative 26. So now let's divide that by 36, and we get our negative 0.72222222. And it goes on forever. But because it's a z-score, we're supposed to round it. How many places for a z-score? Yes, indeed. That's right. It is 2 decimal places. So 0.72. Negative 0.72. All right. So again, not anything too drastic. Just be careful how you put it into your calculator. But now for 16, it says, would the height in number 15 be considered significantly high, significantly low, or not significant, and why? Well, let's see. We got our z-score was negative 0.72. So now you got to think back to significance. What was the range rule of thumb, and how did that talk about significance? How many standard deviations away was those significant cutoffs? Hopefully you remember it's 2 standard deviations away. So essentially, if you're 2 standard deviations away, that means you have to have a z-score of 2 or negative 2. But in this case, this z-score is in the middle between those 2 cutoffs, negative 2 and positive 2. So in this case, it should be not significant. So not significant. And because, now you can do this in terms of an inequality. That kind of gets the point across. So we can see that negative 0.72 is between those 2 significant cutoffs. You can say it in words, because negative 0.02 is between negative 2 and 2. So there's lots of ways you can phrase it. But the big thing is, if we're looking at it in terms of z-scores, it's between negative 2 and 2. If it's too big, if it's larger than 2, then we know it's significantly high. If it's smaller than negative 2, then it's going to be significantly low. So you got those 3 regions. So high, low, and right in between. And if it's in between, it's not significant. So now the last question, what are the minimum and maximum significant values? Now we just want to know what those cutoffs are 2 standard deviations away. And if we kind of look up above, we actually already found them. We already know what those 2 cutoffs are. So the minimum should be 842 centimeters and 986 centimeters. So because you want to do exactly that, you want to take the mean and you want to subtract 2 standard deviations. Add 2 standard deviations. So I'm not going to regenerate the work down here because we already did it up above. But that wraps up this review test. So again, this is not all encompassing. There might be some problems that are a little bit different than what you see on these, but this does give you a pretty good overview of all the different topics we covered so far in this chapter. So, all right, we will see you in more videos to come. Take care.